Alright, if I look at this problem here, I realize I have something to the fourth power, and half of 4 is 2, and that's not 2, so I should be thinking to myself about a greatest common factor. And when I take a greatest common factor, I'm going to do a negative x squared. Raise your hand if you got that. Let me show you why you should have done a negative x squared. If I take a negative x squared, I'm left with what? 2x squared plus x minus 3. The reason why I had to take a negative is because when you're factoring a trinomial, you never want your leading coefficient to be negative.
That's right.
Okay, it's hard to factor like that. Previously in your lessons that if you have an a value that's greater than 2, you have to do both the x and the box. I'll show you really quickly. So you take inside the parentheses, highlight this for you. You're focusing right there. A times c is what? B value is 1. Two numbers that multiply?
3 and negative 2.
3 and negative 2 is correct. Those multiply to be negative 6, add to be 1. Those two values here, you're going to put in your bottom left and your top right. And then inside your top left, you're going to put your leading coefficient, 2x squared. And then over here, you're going to put your last term. Class, what's the GCF of this row?
That would be 2x.
2x. This direction?
X.
And you can multiply to make sure that it equals that box. What's the GCF here? Negative 1. And negative 1 times 2x is negative 2x.
Oh, yeah.
What's the GCF here?
3.
And you can double check 3 times x, 3x. 3 times negative 1 is negative 3. So now I'm going to put in here x minus 1,
Oh, yeah, I got
2x plus 3. Class, can I interchange this?
Yeah, you can.
Yeah, you can because it doesn't matter which order they're in, multiplication.
Right.
Raise your hand if you got that. So when you factor it, this is my answer. So a lot of you probably found the GCF, but make sure that inside you keep factoring, you keep going. How do you know? Well, if you can't factor, it's prime, but if you think it's prime and it's not, then you're wrong.
These are fucking